So today we're going to dive into the AI revolution, but we're not going to do it with a bunch of boring jargon. Instead, we're going to look at the few huge aha moments that completely changed the game. We'll see exactly how we got from machines that just calculate to machines that can actually create. And it all kicks off with a story. It's about a farmer, an advanced AI assistant, and a crop that's about to fail. And believe me, this isn't science fiction. It's a real-world situation that tells you pretty much everything you need to know about the incredible promise and the serious peril of these tools we're building. Okay, so here's the heart of the problem. We've got this amazingly powerful technology that's supposed to help, but at the worst possible moment, it gets it wrong. How does that happen? Well, figuring that out is the key to understanding this entire revolution. I want you to really put yourself in the farmer's shoes for a second. Your whole livelihood is on the line. Your wheat leaves are turning yellow. So you turn to your trusted AI agro help. It comes back with a super confident answer. Nitrogen deficiency. The solution? Fertilizer. So you do it, you follow the advice, but things just get worse. Way worse. By the time a human expert figures out the real problem, a fungal infection, the damage is already done. And that right there is the big question, isn't it? I mean, AgriHelp isn't just some simple app. It's a seriously advanced AI. So how on earth could it get something so critical so completely wrong? The answer actually takes us back to the very first big breakthrough that really defines all modern AI. You see, for decades, scientists tried to build AI by hand-coding millions and millions of rules. You know, if this happens, then do that. But it was so brittle, so inflexible. It just didn't work very well in the real world. The real revolution, the first giant aha moment, came when they flipped that entire idea on its head. And that massive leap, that is what we call machine learning. It's the engine that's driving literally everything we think of as AI today, from AgriHelp all the way to the most powerful systems on the planet. Okay, so let's really break down the difference. The old way was like giving a machine a super strict instruction manual for every single possibility. If something happened that wasn't in the book, it was lost. But machine learning? That's like giving the machine a library card and teaching it how to read everything. It finds the patterns and writes its own rules, which makes it way more adaptive, way more powerful, and the foundation for everything that came next. Now, what's so wild about this is that this new idea, it's not new at all. An AI pioneer named Arthur Samuel defined it perfectly. I mean, we're talking all the way back in 1959. The dream of computers learning on their own has been around for a long, long time. We just needed the massive amounts of data and the sheer computing power to finally catch up with that vision. Okay, so machines could learn from data. That's a huge step. But, learning from clean data in a spreadsheet is one thing. Teaching a machine to understand the messy, chaotic, visual world that you and I live in, that was a whole other ballgame. That was the next great mountain to climb. All right, so this next phase, this is where things really, and I mean really, take off. It's all thanks to two incredible breakthroughs that basically gave machines the senses of sight and language. So, why was it so hard for computers to see things? Well, the early methods tried to match images pixel by pixel. That's like trying to recognize your friend only if they stand in the exact same spot in the exact same pose without moving a muscle. It's useless, right? If a cat in a picture was slightly tilted or bigger, the pixels wouldn't line up and the computer was totally lost. The breakthrough was something inspired by the brain called a convolutional neural network, or CNN. CNNs don't care about perfect pixel matches. They learn to recognize features, like pointy ears, whiskers, a certain texture, no matter where they are in the image. Let's simplify how this works. Think of a CNN as a detective. Step 1, convolution. That's the detective dusting for fingerprints, finding all the basic clues like edges and corners. Step 2, activation. This is where the detective decides which clues are actually important. Step 3, pooling. Now the detective summarizes the key evidence to see the big picture, ignoring all the junk. And finally, classification. The detective takes all the evidence, the pointy ears, the whiskers, the tail, and confidently declares the culprit is a cat. And here's where it all came together in this mind-blowing way. At the ImageNet Challenge, which is basically the Olympics of computer vision, a CNN called ResNet hit an error rate of just 3.57%. Now, to put that in perspective, the average human error rate on that same test is around 5%. So in 2015, for the very first time, a machine could see and classify images in this specific test better than we could. The revolution was officially here. So just like CNNs cracked the code for vision, a totally new design called the transformer architecture did the same for language. Introduced in 2017, its secret weapon is something called self-attention. It basically lets the AI look at an entire sentence all at once and figure out how each word relates to all the others to understand the true context. This is the tech that powers pretty much every single large language model we talk about today. So, let's take a step back. At this point, machines could learn, they could see, and they could understand language. They weren't just analyzing the world anymore, they were starting to perceive it. So what's the next logical step? It was inevitable, really, using that perception to create something brand new. And this right here is the dawn of generative AI. We're talking about a leap from just interpreting the world to actually adding to it, creating images, music, text, and code that have never existed before. One of the most genius ways this works is something called a GAN, a generative adversarial network. Just think of it as this epic duel between two AIs. You've got the generator, who's like an art forger, trying to create the most convincing fake it can. Then you have the discriminator, who's like an art critic, whose only job is to spot the forgeries. The forger makes a fake, the critic calls it out, the forger learns and tries again, getting better each time. This goes on millions of times, until the forger's fakes are so good that even the expert critic can't tell the difference. And this brings us right back to where we started. We have these unbelievably powerful tools that can learn, perceive, and create. But just like we saw with our farmer, with all that power comes real complexity and real risk. So let's get real about what this revolution actually looks like. And look, the promise is just wow. AI is speeding up the discovery of new medicines. It's helping doctors spot diseases earlier. It lets you virtually try on clothes before you buy them. It's writing code for developers, building personalized lesson plans for students. It's just incredible. But the flip side, the peril, is just as real. These AIs can give dangerously wrong advice, just like we saw with AgriHelp. Because they learn from our data, they can pick up and even amplify our worst biases and stereotypes. They can hallucinate, which means they just confidently make stuff up. And of course, the power to create realistic fakes opens a huge Pandora's box of misinformation and deepfakes. So when you boil it all down, what does it mean? It means the technology itself isn't really the barrier anymore. We've done it. We've built an incredibly powerful learning machine. And like any tool, from a hammer to a supercomputer, its impact depends entirely on us, on how we decide to use it. The future isn't written yet. We taught the machine how to learn. The only question left is, what will we choose to build?